Oh, that's hot. That's hot.
All right. Welcome to a new series. We are playing While True Learn. Never played this game before. Looks like we'll just jump right into it. To become a programmer, you must master the art of turning the computer on. Press and hold, drag, press power. Congrats, you're almost a programmer. Sure. This goes to there. We need a keyboard and turn on. Cool. Computer's on. Guy coding, programming, gets a bug, another day, gets another cup of coffee. Cat debugs, build successful. Good job, kitty cat. Meow. Hey, what did you do? What did you do that? Cat overflow. Look at the cat. Welcome to your workspace. Drag and export the system. Sure. Cool. Totals time spent. Great. Final result. One node used. Really programming. A spicy at cat.meow. My cats talk. 1, 2, 3. Behold. Sure. You get 350. Good day. We're from a public school. Summer exams have ended. Could you please process and predict the students will be able to MIT? Okay. I guess we're a cat. Sure. So we need accuracy and also data. So we have 10 results. So green to green. So we're gonna go green up there, else go to blue. It should be fine. Speed it up a bit. This is just a if else statement. So if green, go up there. If else, goes here. Sure, we can release it. 100% accuracy. Nice. Cat cow, so we have to pay for the server. Errors in database. We have some errors. Can we help solve them? Scheme. Okay. We have some things to improve. Sure. Yeah, real world, there's a lot of errors and stuff. So we have a couple of stuff. We have an export system. If blue, we don't need any blue. Else goes there. That should be fine. So I was gonna filter out every single thing that's blue, but we need red and green in there. Uses only one input, and let's throw that into the trash. All right. Looks good. Sweet. We got some money for that. Errors in database 2. Non-neural artifact intelligence. Sure. Example, Lisa was the very first chatbot in the world, created in 1966. It talked. It worked horribly. Sure. If else divide, we got that. Oh, so we already have that. And this is the if else divide, red and blue. Interesting. We just need red. We can go there. Cool. Time is also precious too, right? Accuracy for text. Okay. Decision trees. Different nodes. Decision tree is one of the basic machine learning algorithms. Correct. Each tree. Output stream 1, output stream 2. We have a color decision tree. So either we basically want red or green up here. Gotta do something like this. We put 2 decision trees. Oh. So all of these come into here. Blue and green need to go there. Too many nodes. See it on the top screen. Do this with one node. Interesting. So the decision tree would be it. Red goes up there. Green goes over there. And then I want to use only one node. Why don't we just do, can we use 2 of these? It's a little faster. I mean, this won't work. Oh, why did that work? Decision tree red. it goes to a random socket. If an element color satisfies both conditions or none, it goes to a random one. Okay. Let's go do some optimization on the entries. We have to use a total of 3. Well, wouldn't this be the easiest way? So we need a couple of these guys. So if green, so blue and red will come here. So we need red and blue. Can I add more to the trash can? Yeah. So what this is doing, actually let's switch these up. Let's make this blue and this red just so it's easier to see. So this is going like a cascading one. So essentially we're gonna go input to here. It's gonna divide between red and green, but also blue can go through either one at random. So that goes into the trash. Red gets pushed through and it goes through another filter. So we'll only have red and blue here. Anything blue gets shut down. And this is still faster than one of this expert systems because this is 1 second versus 0.6 seconds, a total of 0.6. Should work. That's why we test. Cool. Release that. This is a tree equals smart tree. Let's proceed. What do we got here? We can only use 3 nodes and we have 25-second limit. We also have per second, that's how much we actually lose. So we have a couple of output systems. Each of them does need, so fastest way is red can go there. Might need 3 of these. So we definitely know blue is gonna go there because it's the only one that's associated, and green can go there. So green's on all of them. So what if we did something like that? So then this would be blue and this would be blue and red. So we have these ones going into here. So essentially should be fine. Really? No, we're only allowed to go in one. Okay. So how do we load blue and green? I think this is fine. So red can go to that one or red. Ooh, but red won't be allowed to go down here. Interesting. What if we did blue or any? So we don't filter on anything here. That goes red. We're good with that. We'll do any, but we'll also do blue. That's the thing. Let's test this. Oh, that works. Okay. I didn't think it would have worked. Oh, this is no green. Interesting, interesting. What if we did one of these as green and this is green? Equal distribution, but we need red. What if we did this? If blue go here, else red or green. This one's a fun one. This one will only get blue, so we can. And then since anyone's going there, we can split this one more time. So that means this gets red and green, no problem. This guy gets red and green, no problem. This guy only needs green. Let's try that. 100% accuracy, just timing wise. What does this do? Just loss of accuracy and ran out of time. Do I just not have any more nod? I mean, blue, so I shouldn't worry about green. Let's make sure blue gets in the right place. So blue will always go in the right place. And then this gives me all the colors. Should be red, red or green. I mean, I was trying to filter out, so I did this, and this seemed to work, but it's not accurate. If red, go there. If blue, go here. Else, go here. Oh, like that. Let's try that. Ran out of time, but we had full accuracy. It's not fast though. 88% accuracy. Oh, because I didn't have any red. What if I did that? So blue gets still towards the bottom, which is not ideal. If I did green. So if I did red up here, does that work? No, and he also gives us blue. And he still gives us blue. Blue gets filtered out. Red goes in there, but green also goes in there. If I'm trying to save all the data. I'm not sure if I have all of the outputs yet, so let's go back. Let's go into here. If else sifting, so node compares shapes. Nice, and then it goes to the top socket. We're at 2 nodes. That work? Success. So we have the most of squares. And circles, and then nothing. I want to see if that's the correct order. Looks like it goes faster if it's on the top. Oh wait, this is optimal. Looks like it is. Can we go back to here now? Does this work? Yes. Cool. That was the solution. I had to think about it a little bit. We have colors and shapes. Beautiful. So red and blue go directly there. But we also need some red triangles. So the most that we have are red squares. So if you are a square, go up to here. Else we need another shift. Circle. If you're a circle, only go up to there. Boom, 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 boom. Let's do red and green. So red and then green. We need red or green, and then triangle needs to go here. Only have 6. Maybe we tackle shapes first. So I do know I need that, that, and that. If I'm a square, and I am green, that's garbage. So we can just do that. That gets rid of all of our greens, right? Our green, that gets rid of all of our green criteria, but it also throws in blue. So if I'm a triangle, let's just see what this outputs. So this separates it to both. Now I need to sift on each end. If anything is a circle, you go there. Anything's a triangle, you go there. Let's see what this does. Okay. And we need a decision tree. So circle, all the circles are good. So all the circles are good, you're fine. But shapes that are not good, like this guy, let's say triangles, go in the garbage. Everything else can go through. The top layer should be good, right? Yeah, top layer is very good. I'm happy with that. Top layer filled up, no problem. And bottom layer, have triangle. If triangle is green, go into there. Triangle is... No, if triangle is green, triangle is blue, go to trash. Boom, boom. Just also give me red squares, that's the thing. That's okay. This gives me red squares, go there. This gives me green and red regardless. So we got green and red. Something like this. Red triangles are getting through. This gives me blue and red triangles. I don't need any of that. It's gonna be everything green and red here. Solve for this guy then. If he is a... So this gives us red squares. Then it gives us every other shape. This gives us green. Triangles. Now I need blue circle. And if this guy's a triangle, I'll just go there. Let's try. No. We'll come back to this one. C-Bay. Okay. Pizza. Only have one. Only allowed to use one. Oh. Since there's no triangles, I don't have to account for them. So just cross that out. Got it. Cool. Okay, now let's try this guy again. So I understand I need this. Keeps blue and green separated, which is exactly what I want. All right, and then red can go to both of them. Now I have to shift for triangles. Triangles go garbage. What else goes in there? That handles all of those, no problem. Now I have green and red. What do I do with green and red? All I need is that there. We could do another. Green and red. The green. If a red one goes, you're good. If a triangle goes, you're good. Else garbage, else garbage. Cool. Sometimes you just gotta leave and come back. Awesome. We'll try one last one. Here, we just click one of the banners. We'll go here, here, here. Get a camera. Dog. Bad machine learning. Emotions. Training. So we can definitely train models. Sure. So that's 75%. So we have to be above 60%. So after you train it once, it's pretty good. Cool. Let's look at some of these other ones. So these are all gold metal, gold metal. These ones are not gold metal. Let's try to fix that. Why is this considered not a gold medal? If blue go. Can you do it with 2 nodes? Green would be good going into there. And if this is blue, we have to go through another one. And this one has to go through here. And these have to distribute appropriately. So if I get any green, what was my solution before? So any red and blue, red and blue. I don't even account for green. And why did this fail? It just wasn't fast enough. What if we did that? If we get all the greens out of here, that would be perfect. And then it's just these two, right? Can I just do any? Is this faster? I don't see why it wouldn't it be. So only blue goes in there. I think this might be it. Because that means this would take any and then it would just go. Alright. This is the fastest. Awesome. And these ones we gotta improve. But I'll take a look at this. Let me just do that. Cool. And we have chicken escape. And we also have this one that's kind of crazy. Let's look to see if we can improve chicken escape. Boop, 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 boop. So let's do opposite. Let's filter for a circle instead. And then let's filter for a triangle instead. And then go like that. We're switching it out because of the quantities essentially. Still. Let's try this. Triangle's going slower. Since triangle is the slowest, let's account for that first. All right. And then square's going the fastest, so let's do account for that. Because square's going the fastest because there's the most quantity of it. Perfect. So we got our model a bit better. And do we want to take a stab at that? Oh, okay. This was kind of crazy. Boom. What if we did something like this? And we had to put all triangles into here. All triangles that are green must go here. Else the triangles go in the garbage. We could try this. The accuracy is just really slow. Alright, we'll take a look at this next time. But that'll do it for our first episode here. Very interesting game. I'm loving it so far. And I'll see you guys in the next one. See ya.
Oh, that's hot. That's hot.